Progress.
So under this recording, we'll be talking about composite functions. We'll be talking about what we call composite functions. So I've got what we call one-to-one functions, and then we also have what we call one-to-many functions. No, not one-to-many, but on-to. You are the right on-to functions there instead of one-to-many. On-to, let's say on-to functions. So yeah, so both have got special names. This one we call it injective function. And then this one we call it the surjective, yeah? The surjective functions. And then we also have the third one. So the third one is a combination of these two. It's when the function is both injective and subjective. Meaning you'll have to check for both. You'll have to check if the function is injective or is injective and subjective. If it's both, then we call that particular function a bijective function. So now let's start. So I'm gonna do examples for both of them. Ne? I'm gonna start with the simple one, which is the injective function. And then we should also talk about the subjective after giving examples. Must give examples of. Okay, so yeah, we'll be discussing the conditions. So under injective functions, here we know what we know is that in order for any function to be injective, let's say f of x, then f of x must be equal to f of y, such that x will always be equal to y. Yeah, so this is the condition for one-to-one. Then with subjective, here f of x must be equal to what y, but depending on what on the set that will be given. So I'll explain what I mean when I say set. But when I say the set that will be given, I'm referring to real numbers, natural numbers, because they're gonna give you something like the domain maps to the codomain. So if the answer that you are and it means the function will be surjective. So we'll do it after the one for injective. So let's do some examples now. So let's say you are having the function 5x minus 2. Then they say show whether this function is a what. Let's start with show that the function is injective. I mean, we must check f of x being fy. such that we know x must be equal to y, right? In the set, let y not be equal to r. Okay, within the set, let's see, such that x is equal to y, no? Okay, they didn't say real numbers or whatsoever. Yeah, so because this one is injective, so I'm going to say we know that our f of x is already given. So for f of y, where there is x, we'll just put y and then we solve. So if we check, we're going to have y minus 2 plus 2. This one will give us 0. Then we divide by 5 both sides. Then x will be equal to y. So the function is what? You can see that the function is injective, or it's a one-to-one function. So let's say the very same example. Let me write it here. Let's say this is show if the function f of x equal to 5x minus 2 is subjective. So if they wanted us to check this, we're going to say, I'm checking for subjective. We're going to say, we know that, let's say they said f, so they were supposed to, write this f maps to f, the domain maps to the codomain. So by these terms, this one is our input value. It's what we call the domain. Then this one, it's our codomain. Right. So what you're going to do, so we must check if whether an input value of x will actually always give us an output value of y, which is a real number. As you can see, the condition, real number maps to real number. So what we're going to do in this case, we're going to say, we can start by saying let y be an element of real numbers, be the domain, be the codomain, sorry, in the set of real numbers, right? In real numbers, such that, so this is the condition, such that f of x, it must map exactly to y, meaning what this means is that real numbers must give us a real number output. So if that condition fails, that means our function is not subjective. So we're going to have, y having y equal to 5x minus 2. So what we're going to do is, what we're going to do here is we're going to make x subject of the formula so that we can check the relationship between the codomain and the domain. So when I say codomain, just know that I'm referring to the output of y. The domain, just know I'm referring to the input value of x. So here we'll have y plus 2, 5x divided by 5 divided by 5, and then x is equal to y plus 2 over 5. Here I'm sure you can notice that this set will always be an element of real numbers, regardless of whatever the value of y of y is. So just say for any y being an element of any real number. So real numbers will map to real numbers. Hence, we can say the function f is surjective. So we can conclude that the function f is bijective as well. Then I said by bijective, we are referring to a function that is both. It is both by surjective. It is both subjective and injective. So that's what we mean by that. And then we'll move to more examples. Right, let's do more examples. Okay, so there was this question on the kite. Was saying so that the function f such that the real number will map to the real number defined by f of x equal to x squared plus 4 is not onto, or let's just say it's not subjective. So you are checking, so we know that we must get that the function is not onto. So I must just prove it or show it. That's what they say show. So given f of x being equal to x squared minus this plus 4. So we know that this is the same as y being equal to x squared plus 4, right? Then if I make a, let's say we make our what? We'll try to make x subject of the formula, but we're going to have y minus 4 equal to x squared, then we'll square both sides, then we'll have x being equal to plus or minus the root of y minus 4. So this is not going to be surjective. So this one will be an element of real numbers as long as y, if and only if y is less than what? Is less than 4. So so we just use yeah, so this is correct, right? It will always be like that, because if this is negative, then we'll get undefined. Therefore, the condition will fail. Codomain and domain mapping to each other will fail. So we can say that the function and the conclusion, the function, but this is how you will conclude f of x is not subjective. Then let's go to the questions that are in our tutorial 2.5.6. I'll just be writing them here. They wanted us to check if whether the following functions are onto or one-to-one. So the first one, we're given f such that real numbers will map to real numbers defined by f of x being equal to negative 3x plus 2. So we must check this one, right? So we're going to first check for, let's change this pen. I'll just use, let's first check for subjective. And so I'm going to say let y be an element of real numbers while letting it, so that we can verify if it's true. B, the codomain are such that f of x is equal to y. Then y will be equal to negative 3x plus 2, such that, then we know that y is equal to this. Then what we're going to do is we'll make x subject of the formula. We'll have this negative 3 divided x will be y 2 over negative 3. And then we can write this as negative into 2 minus y, negative 3. The negatives will cancel. Then we'll be left with 2 minus y over 3x. So what this means, and this is an element of real numbers for any value of y, right? For any y value, let's just say it's an element of what? For all values which are real numbers. Therefore, f f of x is subjective on. So now move to check. We can check if the function is injective. So if we were to check whether the function is injective, it means we're going to say, we can say, assume that f of x. So want to check. That's why I was saying assume, or we can use the weight method of English, or we can say let. Assume, we can say let f of x equal to f of y. Then negative 3x plus 2. This was the original function. Then here we'll just replace with y, right? Negative 3y plus 2. So now what we're going to do from here is to solve and make x and y subject of the formula if possible. So these two will cancel one another. We left with negative 3y on the left. Then we know that negative 3 will cancel negative 3. Then x is equal to y. Therefore, the function is also injective. It's a one-to-one. And the function is what? Is bijective as well. Because I said bijective is a function that is both subjective and injective. Then we move to the next example. Let's say now you are given number 2. Let's say you are given the function f next to r defined by f of x equal to x squared minus 5. So with this one is the one that we have done. Okay, I'll just do the subjective part. We've done something like this. I'm not sure if we've done it. It was exactly this one. Let me just confirm. No, they were different. They just look similar. So we'll just check for subjective for this one. So, and we're going to say let, or we can say assume y is an element of real numbers, b the codomain. Remember the codomain, we are referring to the output. Be the codomain of real numbers, such that f of x is supposed to be equal to y. Then this part is important. Then you know that we have y must be equal to, so this y must be equal to x squared minus 5. And we check, we make x subject of the formula. Then we'll put the square root there, so the answer is positive or negative. So it's not all the elements of y that are going to make this function to be real, right? So just say this is not a set of real numbers. Whenever y is what is less than -5, that's equal to -5. Or someone can decide to say for any y being an element of -infinity to -5. Therefore, f of x is not 1, 2. Yeah, so you guys, you will check for injective. Just check if x will be equal to y. Let's move to the third one. So let's say you were given that f such that the codomain maps to the codomain positive defined by f of x being equal to x squared. So this one, we'll first check for subjective, which is the onto. So I'm going to say let y be an element of real numbers, positive, be the codomain of R plus such that f of x is equal to y. Then I'm going to say y. We know that we must say y is equal to the function here. So y will be equal to our given function is x squared. Then we left the root of y plus minus equal to x. So if we check, number will be having the square root of y, right? So it's either with a plus or a minus. Either with a plus or a minus. So this one, for x being equal to the root of y, element of r plus, progress. So for x being equal to the root of y, this will satisfy element of real numbers for a for any y being element of real numbers. But when x now is equal to the negative root of y, this won't be an element of all positive real numbers for y being element of real numbers. Therefore, so this condition, it makes everything to be. So f is not subjective. Progress. And then now let's check for when y is equal to x squared, then we want to check for injective. You know that the condition says that f of x must be equal to f of y, such that this will imply that x is equal to y. So if this condition fails, then our function is not injective. I'm going to start from y equal to x squared, and then we make x subject of the formula. We're going to get what? Can just square both sides, right? So we'll have x being equal to plus or minus the root of y. This will cancel with that. Progress. So what we can say is that for x being equal to positive root y, this holds, right? It will hold, and then when x, you see, when x is equal to negative the root of y, this is no longer an element of real numbers. Yeah, remember we ended up finding that since x is not equal to y, you'll just say this. Yeah, since x is not equal to y, as long as x is not equal to y, then this thing, it won't be injective. You can also check that one by doing a counter example. So let's do the one for cosine. So something like cosine here. Defined I f of x. Let's shift this, defined by f of x being equal to is equal to cosine x. So we're gonna check for subjective, and then after we check for injective, and we're gonna start with injective. And then here we can do the one for injective. Injective. So we'll start. So with injective, we're going to say let y be an element of negative 1 and 1, be the codomain such that f of x is equal to y. Then the cosine of x, you know that the cosine of x, because we're given f of x, right, it will be equal to y. And then we make x subject of the formula, and then we check the condition. So the condition was that R, the domain will map to, it will give us a codomain that lies between negative 1 and 1. So if you substitute any values between negative 1 and 1 here, you will find that this thing is what? It is giving us an answer, right? So if you substitute any value between negative 1 and 1, you'll realize that you will get an answer. So this is an element of negative 1 and 1. And then we can say that the function is what? The function f is subjective. And then now we check for injective, right? We must check if the function is going to be a 1 to 1. So we're going to say, assume let f of x be equal to f of y. And then we know that cosine x is our f of x, f of y will just replace here with y. Then meaning that we should just check if x is going to be equal to y. So what you can do here, no? It's nothing. You can just introduce the arc cos. Then introduce the arc cos of cosine y. So these two will cancel one another. Then x is equal to y. Hence, this thing is what is injective. Yeah, so that's it about composite functions. Um, think the only thing left maybe will be to check those other ones for let me see.
Progress.
Yeah, the only thing that will be left on this topic is to find the composite. If they say find the composite functions of f of g and gf, given that f of x is equal to 2x squared plus 4. So I'm running out of time, so I'm gonna write it a little bit big, minus 1. So to find f of g of x, you're going to have f, and then you put 3x minus 1. So it means where there is x on the function of f, we're going to put 3x minus 1. So we're going to have 3x minus 1 all squared plus 4. So this will be our f g of x. So with f, with g, f of x, I think this one is obvious that we're going to have g, and then 2x squared plus 4. Then this will be equal to 3, and then where there is x, we put 2x squared plus 4. Plus 1. And we're going to have 6x squared plus 11. And then on this one, you'll just simplify this. You'll get minus 6x plus 1 plus 4, 18x squared minus 12x plus 2 plus 4. Then our final answer here will be 18x squared minus 12x plus 6. So that's when they say find the composite. Then the only thing left will be to know how to get, if they say given a function f, then they tell us to find the inverse, or they say find this, or they can say find this. So I'll make a video on this one. So we're done for today.